Good day, everybody. I'm Bolanle OTEGBAYO. I work at Bowen University, Iwo. The title of my presentation is Lab Applications and Major Results on Quality Evaluation of Yam at Bowen University. The outline is presented, materials and methods, analysis carried out on royal tubers, physiochemical properties of yam starch, chemical properties of yam flour and starch, and significant results. Bowen University has been involved in work package 1 and 2 in the AfricaYamRTBfoods project mainly. And the laboratory applications or laboratory works that we've been carried out are mainly in work package 2. As we all know, the main objective of work package 2 is to translate the user traits captured in the food product profiles from WP1 into laboratory-based quantitative assessments of biophysical and functional properties that can be used as reference values for developing high throughput product profiling in WP3, and also to develop medium throughput methods for some traits that cannot be developed by the HTTP. Now, the materials and methods that we have been using, our materials are mainly yam varieties from Dioscorea rotundata and Dioscorea alata species that are supplied by breeding units of IITA and NRCRI, Umudike. And at times we use identified varieties. We use varieties from identified farmers' fields. The results that we'll present in this presentation will be based on the materials that we collected for period 4, which are 12 varieties of yam, 6 varieties of D. alata, 6 varieties of D. rotundata, and 1 landrace that we got from the farmer's field. The varieties are listed. The methods that we've been using so far, when we want to prepare the samples, we take between 3.8 to 4.5 kilograms. This it depends really on the size of the yam tuber. And then we'll cut the tubers into 5 longitudinal, cut the tubers longitudinally into 4 sub-samples. And each of these 4 samples are used for yam flour processing, starch extraction and starch granule morphology, pounded yam preparation for sensory evaluation, pasting characteristics of fresh yam paste. The reason why we'll use this is to prevent variation generally. So that means that each part of the yam tuber is represented in each of the sub samples. This will allow uniform samples and reduce variation. Now, normally the analysis that we'll do on raw yam tubers immediately we'll start the analysis. We'll do the granule morphology of the starch, we'll determine the dry matter, we do polyphenol oxidase activity determination, we'll do instrumental color evaluation using Hunter colorimeter, and then we'll do the pasting characteristics of the fresh yam paste. We'll also do pasting characteristics of the yam starch. And then what other things do? We'll carry out descriptive sensory evaluation on the pounded yam using trained panelists. We'll carry out instrumental color evaluation of the raw yam tubers and the pounded yam. We'll also do instrumental textural quality evaluation of the pounded yam. And then we'll also determine the chemical analysis of the yam flour. We'll carry out chemical analysis on the yam flour. Now this figure is like a schematic diagram of how we prepare the pounded yam in the lab. We start from the raw yam tubers. The raw yam tubers are peeled, the tubers are diced into cubes, and then the yams are boiled in the boiling unit of the yam pounder, and then it's also pounded in the boiling unit, in the pounding unit of the pounding unit of the pounded of the yam pounder. Actually, the reason why we're using the yam pounder is to make sure that all the yam varieties are pounded the same way, using the same amount of water, using the same amount of time to maintain to have a uniform processing method for all of them. Because if we say, okay, we'll be pounding using pounded yam, you know, there will be variation in terms of the physical strength of the pounder or the amount of water and things like that. So we want to get a uniform material. So when we finish pounding in the yam pounder, then we quickly pack it in a foil in samples, in sizes that are easy for the panelists to be able to evaluate. Then we'll maintain the temperature by putting them, we'll call it eating bowls really, because it's electrically operated. We'll just connect it to electricity in order to maintain the temperature. And then we'll carry out descriptive sensory evaluation. We've already produced an SOP on descriptive sensory evaluation of the pounded yam. This can be discussed later. And then the sensory evaluation session is carried out. Thank you. Actually, this other chart is showing the type of pounding yam machine that we use. This is common in all the institutions where we are carrying out pounded yam evaluation in the RTB Foods project. And from the work so far, we're able to identify, even when we are pounding it using the pounding yam machine, we're able to identify yam varieties that will produce good pounded yam. From the pounding, you can see this one, right in the yam pounder, you can see what we have obtained. Thank you very much. And after that, this is the sensory evaluation method that we use. We select the panelists. Usually we use about 15. You know, they are trained panelists. So we select them based on availability. We select them based on familiarity with the consumption of pounded yam. We select them based on interest and previous experience on sensory evaluation. Then normally, during the training session, we introduce the objectives of the study, and then we do vocabulary development. What are the quality attributes? What are those things? How do we do it? And definitely, then after that, we identify the textural quality attributes of pounded yam using local food descriptors to exemplify those attributes. For instance, there is a product that we use, one of our local products, we call it Lafu fermented cassava flour. It's a very stretchable local food product. We'll use it to exemplify stretchability in pounded yam. Then we'll carry out the sensory evaluation. The panelists try it several times over and over until we see that they've really gotten what we want them to get, and then we'll do the sensory evaluation. This is an example of our training session, and then this is the real sensory evaluation session. Now, we'll also carry out instrumental texture quality evaluation. As we have said, instrumental texture quality evaluation is very, very dimension sensitive. Very, very dimension sensitive. So in order to get a product of uniform dimension, we normally, after pounding the yam, we'll put it in plastic molds. These plastic molds are of uniform size, uniform length, and uniform diameter. So we'll pack it in these plastic molds. So when we're ready, we'll put it in the eating bowls like we did for the sensory evaluation, just before the sensory evaluation, and then we'll put it on the texturometer. The probe that we normally use is the flat-ended cylinder probe, which is 45 mm and 75 mm in diameter. We can also use the one that is 300 mm and 75 mm in diameter. This is actually, I've explained it, this chart, and this is how we'll do it. The time between compression is usually 1.5 seconds. Initial speed 5 mm, and then our compression distance is 75% strain, and then we'll run it on this. We have written the SOP. We are waiting for the validation. Thank you very much. This is the flow diagram for yam starch processing and also the flow diagram for the yam flour processing. Let's go to the results now. From the results, remember I said that I will base the results on the yam that we have collected in the period 4. I will only summarize. So I'm just saying that from the results so far that we have gotten from these varieties, I'm presenting the summary results. The D rotundata, we can see the length, and the D alata. I want us to note that in some D rotundata, the length can be more, the breadth can be more. It may be between 20 to 49 micrometers. But these particular varieties that were collected in January, February, they were freshly harvested. These are the results of the granule size that we got. Thank you very much. But actually, these ones can be classified as medium-sized starch granules. And these are the shapes of the granules. So the granule morphology gives us the size and shape of the rotundata starch, of the starch granules, the Ascoria starch granules. Why are we doing this? This is very important. The size shape can identify the variety for us, but actually the sized starch granules determine a lot of functionality of the yam, like the swelling power, the viscosity, the water absorption parameters, water absorption capacities, etc. So the result of the instrumental color measurements of the raw tubers, don't forget, just stick to we are presenting the result based on the yam collected in period 4. So we discovered that the lightness parameter for this particular set of yam, the D alata were much more whiter than the D rotundata. I know you asked that, what is the reason why? The reason is that the D rotundata we collected were more of creamish and yellowish in color, whereas the D alata were whiter. And we actually confirmed this from the breeders. And this is it, the summary of it. We normally do it at 0 minutes, immediately that will peel, and then at 10 minutes in order to calculate, to be able to know the browning rate or the browning index in the yam varieties. So as I said earlier, the D alata, for this set of yams were lighter in color, whereas the D rotundata were creamish and intense yellow color, as shown by the higher value of B index. Actually, the A index measure the red to green axis, and the B measure the yellow to blue axis. The L measure the lightness or the whiteness of the yam. And we also determine the polyphenol oxidase activity to know which one has the highest polyphenol oxidase activity. This can actually influence the browning rate of the yam varieties. So we determine the polyphenol oxidase activity by the absorbance over a period of 100 seconds for both species. And for this set of yams, we see that for the Dioscorea rotundata varieties add significantly higher browning rates or add significantly higher polyphenol oxidase activity than those of the G alata varieties. And this is it, we can say it. We started from 0 seconds up to 100 seconds, and we see that the PPO activity of the G rotundata were much more, the absorbance were much more higher than that of the raw D alata. Now we also do pasting properties of raw yam tubers. Pasting results from the combined effect of swollen granules of starch and exudation of amylose from granules, leading to formation of a less or more thick paste. And the reason why we're doing the raw yam tubers for the pounded yam is that we looked at it. We are trying to look at what can we use to measure stretchability in pounded yam, because over the years since we started this RTB food project, we have been saying that we need to have a proof of concept or to develop a methodology to measure the stretchability in pounded yam. So we looked at it and we said, okay, since the whole of the yam goes into the pounded yam, maybe we should try the raw material, the raw tuber itself, and not only isolated starch. And from the results, the peak viscosity, the holding strength, and final viscosity of D. rotundata were higher than that of the D. alata species, but there was no significant difference in their peak time and pasting temperature. That is, maybe their gelatinization rate and cooking. And this graph is also showing it. We can see that from the raw tuber, something interesting is still coming up. The final viscosity of the D. rotundata was actually higher than that of the D. alata. This is the graph. And then when we got to the pasting properties of the yam starch, we still had almost the same result. But if you look at it, the final viscosity was almost the same thing. And then this brought us thinking that could it be that other components in the raw yam, we use the whole of the raw yam for the pasting characteristics of the raw tuber, but we use isolated starch for the pasting characteristics of the raw starch. And we look at it that could it be that there are some other raw materials? Actually, yes. There are other raw materials in the raw tubers that must have influenced the pasting characteristics of the raw yam tuber. Now, I will still go back to that because when we did the canonical correlation analysis, we got some interesting results based on the fiber, and this is what we are still trying to look at. So the chemical composition of the yam tubers are presented, of the flour from the yam tubers are presented. We also did the chemical composition of the yam starch too. And then we did the anti-nutrients. The anti-nutrients show that D. alata had higher tannin components, but D. rotundata had higher phytate. Thank you very much. We did that of the flour and that of the starch. Maybe we didn't have to do that, but we did. And then getting to the sensory evaluation of the pounded yam. The sensory evaluation of the pounded yam actually showed that the sensory evaluation showed that the D. rotundata were smoother than that of the D. alata, though some D. alata too, we can say it, were much more. The range of the smoothness was based on big lumps, 0, and then no lumps, 10. So we see that the D. rotundata actually had no lumps. They fell between the range of 0 to 1. And then we looked at the adhesiveness and stickiness, which was based on non-sticky 0 and then maximum stickiness 10. Both of them were between 3 and 4. So that means they were slightly sticky. And then we went to the moldability and we saw that based on the moldability, not moldable 0 and then very moldable 10. So we saw that D. rotundata was more moldable. I want to say that these scales that we used is based on the SOP that was developed for pounded yam, and that is what all of us, all the institutions working on pounded yam is doing. Thank you very much. And then the summary of the color of the pounded yam is seen here. We have explained that before. And then we did the texture profile analysis using instrumental method using a texturometer, and we were able to get the profile of pounded yam with good textural quality and that of the one with poor textural quality. We can see that the one with good textural quality was almost smooth, but the one with poor textural quality had shoulders. We can also see it, we now looked at it, the alata pounded yam with good textural quality, we can see it, and the alata pounded yam with poor textural quality with shoulders. And then we correlated the result of instrumental TPA and sensory evaluation. We discovered that there was correlation between cohesiveness in ITPA and sensory. The parameters were correlated are actually presented in the table, and then we can see them in bold colors. The same thing for D. alata. And then the canonical correlation analysis we did. And then we said we got some interesting results from what we have seen so far. From chemical properties of flour, we see that the parameters that are correlated for adhesiveness, amylose, stretchability, crude fiber. As I was saying, this relates to what I mentioned about the pasting characteristics. This is getting funny to us because we saw it in D. alata and we saw it in D. rotundata. We don't know the reason. We're still thinking about it. Adhesiveness, starch is an indicator. Moldability, starch content is an indicator. Hardness, amylose is an indicator. Stretchability, property of the starch, we see that the pasting characteristics is there. And also the raw material, we see the pasting temperature and then the pasting characteristics. For the functional properties, of course, the adhesiveness and hardness, we see that water binding capacity and solubility. Also, in D. alata, we got almost the same results. So we are trying to conclude that pasting properties of starch has a lot to do, can indicate the stretchability of the pounded yam. We are yet to conclude. We are still working on it, but this is our results so far. Now, conclusion, I will just summarize the results. Instrumental color could be an high throughput method for color measurement. ITPA can be a medium throughput method to evaluate textural quality of pounded yam. Pasting properties of yam could be a medium throughput method for traits such as stretchability in pounded yam, essentially pasting properties of raw yam tubers. We are still working on this. Thank you very much. Acknowledgements, BMG Foundation. There, PMU, thank you very much.